This lesson is the final one in the artificial intelligence section, and we'll be covering how backpropagation of errors actually works and how regression methods are used in machine learning. Now, you might have encountered these terms when we were discussing the various different models for machine learning and how deep learning and neural networks work. So it's quite apt for us to understand these two vital terms in a bit more depth. So let's start by looking at backpropagation. When you're designing neural networks, each neural connection should be given a random weighting. The problem is that the designer won't know which combination works best. Therefore, it's important to train the system during the developmental stages to ensure that it produces the most optimum output. A backpropagation-based system will have two stages, the training stage and the testing or implementation stage. In the training stage, inputs to the model are fed into the algorithm, and the system learns from the inputs used and the corresponding outputs, because it produces the outputs which are then fed back into the system as well to train it. So both inputs and outputs are fed into the system to tweak those weights. Once the system is ready, we start testing or we might start implementing it. At that particular point in time, the inputs to the model allow the algorithm or the system to predict the outcome, and that's the output which we want to get, the optimum output. This is an iterative process. Output is compared to the expected output, and differences are calculated and worked out. And these errors, for example, the differences, are propagated back into the neural network to update the initial weightings. This keeps on being repeated until we get the desired output, or we are within an acceptable range of tolerance, because often you can never hit 100% perfection, and you shouldn't even try to get to 100% perfection, because the system is going to keep on tweaking all the time. As long as you're within a significant degree of confidence, you might want to draw the line there. So the summary of the backpropagation process is as follows. Initial outputs compared to expected outputs, and the system weightings are adjusted to minimize the differences. Calculus is used to find the error gradient in the output, and results are fed back into the neural network to adjust the weighting of each neuron. Now, this can be used for both supervised and unsupervised systems. Once the errors are eliminated or they're within an acceptable limit, the neural network is now functioning correctly. If the errors are large, then the weightings are altered and the process continues till acceptable results are obtained. Now, each of these will give you a mark point in an exam, so make sure you understand this process. The graph on the screen simply highlights how the error gradient is worked out. You've got the error on the y-axis and you've got the weights on the x-axis, and we've set a minimum error goal that's what is acceptable, and there's a weight associated with it that we need to calculate. If for some reason that input generates an output which is not the correct one, we adjust the weights accordingly, and the whole goal is to bring those weights down to that one that falls on the error line. And the system will do all of this automatically. It's going to try another value for the weight, and then it'll work out the output again. If it's not the same, then it'll try another value, and it'll keep adjusting it. It'll keep bringing the points down from the top by either increasing the weights or decreasing the weight, depending on which side of the line they fall, and it calculates it for you. Now, we don't need to understand the mathematics behind it quite yet. Of course, if you are interested, you can read a lot more about this particular process. We just need to know that we use advanced calculus or mathematics to work out this error gradient, and we can then use those figures to adjust the weight. Now, there are two types of backpropagation: static and recurrent. Static maps static inputs to static outputs, and the mapping is instantaneous in static. Now, these kind of networks are capable of solving static classification problems like optical character recognition or OCR, where you recognize the characters in text. Recurrent backpropagation, on the other hand, is employed in fixed point learning. What does that mean? Well, the activations are recurrent in nature, and they are fed forward till it attains a fixed value. So we do not know what the weight is, so we can't just simply map it statically. Okay, this is what an A looks like, and have you recognized an A? Static input, static output. But what if we did not know what the character was in the first place? So we keep on feeding what the value is forward till it attains a fixed value. Following this, an error gradient is calculated. Well, okay, we were supposed to recognize an A, and we haven't told the system that this is an A. Eventually, it recognized it as a B, and then we're going to feed this error back into the system. So the error is propagated backward. The key differences are that static backpropagation offers immediate mapping, while recurrent backpropagation is not immediate. You have to feed things forward until you get to that error, and then you feed the error backwards. Now, this leads to some disadvantages for backpropagation. For example, it's very sensitive to noisy data. Performance can be highly reliant on the quality of the input data, needs excessive time for training as well. But the benefits are that we can use it to recognize things which the static mapping might not be useful for. So it's very useful in the field of speech or facial recognition, where we don't actually know what face we'll get to see. That's why it's very powerful. So I kind of think of it this way, that recurrent mapping is more likely to be used for unsupervised systems, whereas static might be useful for supervised type systems. So think of recurrent as having a short-term memory where it remembers what it's doing and the recent past, so it can work out what the error was. Whereas static simply says A, is that an A? If it's not an A, error. If it is an A, it's fine. So the error basically gets propagated at the start of the process for static, and for recurrent, the output is normally added to the input and fed back to the same layer. And generally recurrent is time-based, so it's going to remember a huge amount of iterations compared to static, which will be fixed. Both static and recurrent suffer from a problem known as the vanishing gradient problem, that as you propagate the errors back over time, the gradient actually ends up vanishing. Recurrent networks suffer a lot more on this front, as you constantly feed back output to the same layer time and time again. If you're interested in this area, there's a lot of videos and information out there which can give you a good understanding into the technicalities of how this works. But for the purposes of our syllabus, all you need to know is there are two types of backpropagation, static and recurrent, and you should be able to explain how they work. The final part we're going to look at is regression, and machine learning uses this, especially in supervised systems. It's just the use of statistics. So regression is a way of analyzing data before it is input into a system or a model, and it's used to make predictions about the link or relationship between input and output. It helps us in understanding how the value of a dependent variable changes when the independent variable is changed. So if we change the input, what relationship does that have to the output? This makes it valuable for prediction applications such as weather or share forecasting. And in machine learning, it is used to predict the outcome of an event based on any relationship between variables obtained from input data, and perhaps even the hidden parameters. That, okay, if somebody input this and the hidden layer has this weight, what relationship would that have to the output? All of those kind of statistical analysis are part of regression. All you need to know is the definition of what regression is, what it does, and how it operates. So hopefully you understand how backpropagation works. You understand that there are two types of backpropagation, static and recurrent, and you should be able to answer why regression is used in machine learning. To questions like these, all you need to do is have description-based answers. Regression is used to analyze the relationship between the input, the output, and the hidden parameters. It uses statistical analysis, and so on. That's all for today. If you do have any questions, please do get back to me. Otherwise, I'll see you in the next one.